Good afternoon, morning, in whatever time zone you're in. Thank you very much for joining us in this live webinar that marks the release of the EPIC-KITCHENS-100 dataset. We particularly thank those of you joining us in less comfortable times of day at your end. Of course, we acknowledge that we're starting this seminar on challenging times with this global pandemic, so we hope we find each and every one of you and your families safe and healthy. In the next 2 hours, we'll be telling you about EPIC-KITCHENS-100, the dataset, from collection to annotations, all the way to the challenges. And each member of the team will be presenting parts of the webinar. So we will start by a quick introduction. My name is Dima Damin. I'm an associate professor in computer vision at the University of Bristol.
Hi, I'm Hazel Doherty. I'm a final year PhD student at the University of Bristol.
I'm Giovanni Maria Frinella from University of Catania.
Hi, I'm Antonino.
Got a little bit cut off, Antonino. Yeah.
I'm Evangelos Kazakos, a third-year PhD student at University of Bristol.
Hi everyone, I'm Gemma. I'm a first-year PhD student from University of Bristol.
Hello everyone, I was at University of Bristol where I took my PhD, and now I'm a research fellow at Nanyang Technological University in Singapore.
Hi, my name is Jonathan Monroe. I'm a third-year PhD student at the University of Bristol.
Hi, my name's Toby Parrott. I'm a postdoctoral researcher at the University of Bristol.
Hi, I'm Will Price, and I'm a third-year PhD student at the University of Bristol.
Hi, I'm Michael Ray, and I'm a research associate at the University of Bristol.
And this is the team that will tell you more in the next 2 hours about EPIC-KITCHENS. There is a chance for you to ask questions, so there is a QA button for you throughout the conversation. Also, if you are live on YouTube, there is a chance for you to ask questions there. There will be 2 Q&A sessions. As you will see, there are 2 main sessions, and there will be a Q&A after each one of them. But let's start by kind of talking about why we're here. Is it yet another data set we're currently presenting? We have lots of data sets around, and we wanted to tell you a little bit about the motivation behind collecting this data set in a slightly different manner than what's out there. So typically in machine learning in general, and some of the ideas in this slide comes from a talk by Professor Madry at the workshop on adversarial machine learning a couple of weeks ago in CVPR. Typically, a machine learning researcher or a computer vision researcher would think about a real world problem, let's say object recognition. And the first thing they would do to solve that real world task is to collect some sort of a data set. So that would be them thinking, okay, it's object recognition, so what objects are we interested in? For example, they might come up with a hierarchy of objects, take each one of them, search online what's available about that particular category, collect representative sample images or videos, add them to your dataset. Once this exercise is concluded, then we go into a different cycle, a cycle where we have the dataset, we're training a particular model, and then we are kind of evaluating the error on the test set. And as we evaluate that error, we kind of keep iterating and refining our model, believing that we are solving the original task that we came up to solve, object recognition. Now, this kind of loop continues until a new, typically bigger data set comes to play. And then we realize that the proxy data set we've been working on might not be the best possible representation of the real world task. And even though this is really improving the world of research, we think there is a particular problem because this type of loop applies to most of the machine learning research tasks, from object recognition to action recognition, where data sets we focus on the data set overfitting on it. It's useful for one task. This is the task for which the data set was particularly collected. And then we're biased by the choice researchers made as they collected that data set. And we tend to forget these choices as soon as the data set is out. And they tend to be unnaturally balanced because we tend to collect data sets that are nearly balanced. So they don't relate to the prior on particular object or actions in the world. There is one exception to this machine learning in practice approach. And we would like to argue that this exception is the area of research that's closest to being really applied. And that's the world of autonomous driving. So in autonomous driving, and Kitty is an example, the first task is to put sensors and cameras on a car. You let the car go around the world collecting data, and then you end up with a series of potential tasks from stereo to odometry, tracking, etc. But these are only thought about after you've collected the data, making the dataset itself suitable for a variety of tasks rather than only one. And that's exactly where we started more than 2 years ago now by saying, let's first collect the data and then think about how many tasks we can add on top of this dataset. Let's not bias the data collection. And that's where EPIC-KITCHEN-100, which we hope you're here to joining to know more about it. And that's the motivation for collecting EPIC kitchens and the extension. So what we did is we gave people cameras and asked them to go to their kitchens and collect everything they're doing in their kitchen without giving them any further instructions. So it's all the way from preparing their coffee in the morning to washing the dishes in the evening. And if you spend some time looking at the footage, you'll realize that they have a lot of things that you might not capture, like people thinking about what they're doing, changing their mind, realizing, oh, I need to steady the tray, so I need my gloves back, etc. This absence of instructions allows you to collect data that is what we believe fairly representative of how people interact, in this case, with their objects in the kitchens. What we release are these untrimmed videos. So it's from the moment the video is captured until the camera is stopped. And it is unbalanced naturally. So this is the actual representative sample of the amount of times you do a particular action or you use a particular object. Additionally, we didn't design which type of actions and objects we would want to label. These come from the narrators themselves, the people who have recorded in their kitchens. So what they give us is some sort of a narration, a description of what they've done, which we parse to provide minimally overlapping classes. And finally, what we've released is the video also with the audio, and by that means the event natural sound. So you will see that that captures the sound of the action as well as the surrounding sounds, like in this case, the frying of the chicken. On the 10th of April, we released the first version of the dataset, which we called EPIC Kitchens. It has been very well received by the research community, and that encouraged us to collect the extension. So why EPIC-KITCHENS-100? We hope by the end of today, we would have shown you that this is not only a bigger dataset, but primarily it's better, denser, and focuses on this concept of multiple tasks. So we're releasing further challenges, which we will describe and tell you more about. So quickly, an overlap between EPIC-KITCHENS 55 and 100. And this naming convention comes from the number of hours we've recorded, right? So we're recording the previous version, EPIC-KITCHENS 55, and the new extension, which goes up to 100 hours of collection, EPIC-KITCHENS 100. This increases the number of kitchens and videos, significantly increases the number of action segments, and we'll tell you more about how the density has been increased. There are a lot of new actions that appear in the additional footage. We haven't designed these. They come from the natural collection of additional footage. But importantly, we actually decreased the number of verb and noun classes, removing some of the ambiguities. And we provide new splits and new challenges. And over the course of the next hour and something, we'll tell you more about that. This is just an overview of the differences between what you've seen 2 years ago and what we have released earlier today. In terms of actual counts of action segments, you can see in the archive paper we've released, for each of the action, we show in shaded colors, and this is a linear split, how many actions come from the previous footage, how many come from the new additional footage. And some of the classes are completely new, so the whole bar is actually solid colored. We also group these verbs so that we understand them better. So we say take and remove and scoop are all retrieving actions, while wash and dry and scrape are cleaning actions. And this type of understanding of types of actions and verbs is something that people can utilize in their research. That's the same we've done for nouns. So you can see also in the noun histogram, the nouns that come from the original footage and the additional footage with new classes being added. And also we've released this categorization that groups things like the tap and the fridge and the hob and the oven into appliances. Interestingly, we are also looking at 2 additional questions. One is, how much data do we need? So we increased from 55 hours to 100 hours. Do we need to increase that to 1,000 hours, 2,000 hours? And one of the questions we show is that if you start with that new test set, so this is the test set for EPIC-KITCHENS-100, and you only use the footage you collected 2 years ago, so that gives you the first bar. You're getting around 20% top 1 accuracy. As we add more of the data, so we add a quarter, 25%, 50%, 75%, you see the saturation. You see that it's not linearly, the performance isn't linearly increasing by the amount of footage. And that saturation is even more evident if you look at what we call unseen participants. So participants that are not part of the training set. So that's one of the things that identifies that it's not only about the data collection, we do need different, better models. And in this case, we're using slow-fast, which is one of the state-of-the-art architectures for action recognition. The other question we set to ask is, would models we have trained on data collected in 2018 be automatically applicable to data we collect 2 years later in this example? And it's the same hypothesis. We still gave people cameras to record everything they've done in their kitchen. And what you can see at the first bar, so this is the original test set, and the last bar is the new test set. So the test sets look comparable in complexity. But if you take training only from 2018 and you test the new footage, you see this big drop in performance. We call this the test of time challenge. Could data collected survive the test of time? And again, you see the saturation effect for various different action recognition models in this example. EPIC-KITCHENS-100 is today released. You have access to all the videos, frames, and optical flow. You have access to the annotations for the training and the validation. And you also have the archive paper, which we put out last week. The leaderboards to test and evaluate on the test set are due to be open towards the end of August for 6 different challenges you'll hear about at the second session of this webinar. In the first session, we'll tell you about the collection aspect and annotations, and these are like bite-sized talks. And then in this, we have a Q&A session. So again, this is a reminder for people who've just joined us to use the Q&A option for attendees to put your questions, and we'll address them during the talk as well as during the session, as well as during the Q&A, before we move into the challenges and benchmarks. And I'll hand over to Johnny to tell us about the data collection.
Hi, I will talk about the data collection process for EPIC-KITCHENS-100. So we gave a series of participants GoPro Hero 7s. This differs from the Hero 5s we used 2 years ago for EPIC-KITCHENS-55. So the collection of the footage has occurred 2 years after EPIC-KITCHENS-55, and participants were asked to record all kitchen activities over 2 consecutive days. So this gave unscripted, natural actions. The data we got back was full HD video with audio, and for the extension, we've also got this gyroscope and accelerometer data from the GoPro itself. And on the right, you can see a picture of an example participants, the similar setup that we would have had for the collection of footage. So in total, EPIC-KITCHENS-100 contains 37 participants. The extension in EPIC-100 is filmed by 21 participants. Of the participants who were filmed 2 years ago for EPIC-KITCHENS-55, 16 kindly agreed to record additional footage for EPIC-KITCHENS-100. 8 of these returning participants, 8 had stayed in their same home. Therefore, these have filmed in the same environment as in Epic Kitchens, Epic Kitchens 55. However, the filming is taking place 2 years later. I'll show you some examples of these participants. And from a different participant in the same kitchen. Eight of the 16 participants, however, have now have moved to a different home. So these are filmed in a new environment. So I'll show you some examples of the footage from these participants. So on the left, we have the footage from Epic Kitchens 55. And on the right, we have the footage collected 2 years later for Epic Kitchens 100. We also have participants who didn't collect data in Epic Kitchens 55. So these are new to the Epic Kitchens 100 due to the collection in the extension. In total, we have 100 hours of footage, 700 untrimmed videos across 37 participants. Thank you very much.
Hi, I'm Will, and I'm going to be discussing a bit about the annotation pipeline. So first we'll have a look at a very high level how the annotation pipeline works, and then I'll pass on to others who are going to be sort of drilling down into more detail. So the goal of the pipeline is to take a video just like you've seen here, which could range from a minute to possibly even an hour, and then produce a list of action segments. Here. So those action segments are denoted by a start and a stop time, a narration, and then from that narration, we extract more structured information. So, for example, the verbs and the nouns in the narration itself. So at a high level, this is what our annotation pipeline looks like. So this might be a little overwhelming because there's a lot going on here, but you'll find that it's actually not too bad. So these ellipses here indicate the process, which produces some aspect. So for example, we might get videos out or narrations out. And then we have these white boxes which indicate inputs or outputs from our processes. So once we have videos, the first step is for the participant to narrate that video. So that gives us an audio description of the action being performed. So we developed a piece of software to enable people to annotate the actions they'd performed. So they'd watch back the entire video.
Put down pita bread.
And you can see that they're annotating as they watch, so it's not too much of an imposition. So once we'd done that, we would have audio descriptions of actions along with a rough timestamp of when that action had occurred. So the next step was then to take those audio descriptions and to transcribe them to text. So we tried to do this using automatic speech recognition, but we didn't really have much luck with that. So instead we had to turn to crowdsourcing, and we used Amazon Mechanical Turk, asking workers to listen to the audio and transcribe it to text. So now we would have a textual description of an action along with a rough timestamp, and that would enable us to annotate the start and the stop times of each action. So we asked workers again on Amazon Mechanical Turk to annotate the start and the stop times of 10 consecutive actions. And then this would give us a textual description along with the start and the stop times of these actions. So the final step then is, how do we go from these textual descriptions to something more structured, which we can use to train a model for recognition? Well, we use natural language processing to enable this step. So the first thing we do is that we parse the narration, and this gives us part of speech tags, which you can see along the bottom here, and dependency information between words along the top. So this is the part of speech is typically sufficient for extracting the nouns, but when you want to extract verbs, you typically want a bit more than just the verb itself. So we also take into account the dependency information. So here there's a prepositional relationship between the verb take and the add position off here. So we know that we're taking off something rather than just taking something. So that gives us a verb and a set of nouns for each action. But the problem then is that people use a rich vocabulary to describe what they're doing, right? So people are using different words to describe the same fundamental action. So we have to cluster these into sort of semantically homogeneous groups. Again, we tried automatic approaches for doing this, but they failed us. So we spent quite a lot of time manually doing this. As you can see here, we're all grouped around a massive sheet of paper, which contains every noun that was uttered in our data set. And we're grouping these together. So we kind of worked off the clusters that we had from EPIC-Kitchens 55 and adjusted some of the errors that we previously had. And there are also some sort of contentious things like, should the word fat be grouped with meat? And is a juicer an electrical appliance, or is it like a handheld appliance? And in these sort of cases where we couldn't quite agree, we'd go back to the videos and actually see, you know, what was actually happening here. What was it a handheld juicer, or was it an electrical one? And like any large group project, you've got a lot of people working hard and some of them not working so hard. So that enabled us to have go from our videos to a set of action segments with class labels. So then we had to split our data set. So our training set is composed of videos captured in 2018 and in 2020. We now have a validation set, which I'm sure those of you who've used the dataset before will be pleased to hear about. And this is composed of the sort of previous test set, although we had to move a few participants from the unseen kitchens test set into the training set. And we have a new test set. So this is entirely new videos. And these were selected quite carefully. So for example, we wanted to make sure they all had good lighting, that they were sufficiently long. And one careful consideration we had to make was that we didn't have too much washing up in our test set because we have a large quantity of washing up videos. And then finally, we also have a few unseen participants in our test set, which enables us to test models' generalizability to new environments and people. So as a recap, in EPIC-Kitchens 55, we had this training set and two test sets. These two test sets were a bit of a pain to work with at times. So, you know, those are gone now. We have just a fairly normal train, validation, and test setup. So life should be easier for people. But we still want to maintain some of the nice aspects of these dual test sets where we were testing generalizability, but now we just evaluate on subsets of the test set. So for example, here we're testing models performance purely on instances from unseen participants. So that concludes your whistle-stop tour of the EPIC-Kitchens annotation pipeline, and I'll hand over to each individual who is responsible for each of these processes, and they'll tell you a bit more about them in detail.
Okay, so we saw that one of the first steps of starting our narration pipeline was to collect narrations from our participants. For EPIC-Kitchens 55, we adopted a live commentary approach. That means that our participants were simply watching their videos and they were narrating the actions in the video as they were watching it without pausing the video. And we had quite a few issues with that approach. Namely, because the video and the audio tracks were not synced, we had quite a considerable misalignment between the narration timestamps and the occurrence of the action in the video. And also because our videos contain actions that often take place in a very quick sequence, one after the other, and because the participants were not pausing while they were narrating, we had quite a few missing actions. For the same reason, some participants were trying to speak fast in order to catch up with the video. And as a result, we had a few rushed narrations that were a little unclear. So we designed a narrator tool, which we nicknamed the EPIC narrator, to try to solve these issues. The EPIC narrator is essentially a video player, with audio recording functionalities. You can play a video like you would normally with any kind of video player. You can move backwards and forwards. You can mute or unmute the audio and so on. The main idea is that you play the video, and when you see an action, you click the recording button, and this pauses the video. And this is actually the main trick, because now the video is paused while we narrate the actions. We are no longer missing any actions as we speak. And also because we're using a dedicated interface, the narrations are now synced with the video. And because the video is paused, there is no need to rush to speak. Once you finish narrating your action, the recording is saved to disk, and the video resumes automatically to facilitate faster annotation. Via the interface, you can also you can listen to, delete, or redo a narration through the recording panel. And this further increases the quality of the overall narrations because the user can check their work. And you can also change the playback speed, so you can annotate fast actions better. In fact, we see each of these tips in the slider corresponds to an action. So we have quite a lot of actions in our video. And you can also listen to the narrations as you watch the video after you have recorded them. So you can check that you haven't missed an action in the video. And I'm going now to play a video demo of the narrator interface. If it just a second. Open cupboard, pick up cereal, close cupboard, put down cereal, open cupboard, pick up cereal box, pick up cereal box, open cupboard, pick up cereal box, close cupboard, put down cereal, pick up cup, put down cup, move cereal, it's also easy to narrate long videos over multiple sessions with the narrator. This is because the narrator remembers a few things. For example, he remembers the last video that you opened, and importantly, the playback position, so the point where you left annotating. And he also remembers where you saved your narration to disk, as well as all the other settings. We released the EPIC narrator today, and it's written in Python. It's open source. You can download it already at this repository. And the narrator runs on Linux and macOS. For Linux, we packed the app with Flatpak, so you don't need to worry about any dependency. It just runs like a binary, and it runs on all distributions. For macOS, you will need to use MacBrew and pip to install the necessary libraries. For Windows, we haven't ported it yet to Windows. However, this is theoretically possible because all the libraries that we use for the narrator are also available for Windows. Thank you.
So I'm going to talk about the transcription and
temperature on hold.
Translation process. So as you just heard, there's some audio narrations from the EPIC narrator, which we want to be able to transcribe into English text like this.
Pick coffee pod.
And then there's also, as people narrated in their native language, narrations in other languages.
Apri cassetto.
Which we also want to transcribe into English, so we can do the same parsing and clustering on all of the narrations. Now in EPIC-KITCHENS-100, we'd noticed some difficulties with the transcription process. So some words like hob may be unfamiliar to some of the transcribers, and some words, as you just heard, can be hard to determine what they actually are. So is it a coffee pod or is it a coffee pot? And then there are other words like draw, which can be, which will sound the same but can be spelt differently, and also flower is another example of that. Now these things can be easily disambiguated by adding images. So now we can see that it is indeed a coffee pod and not a coffee pot, and that a hob refers to something like a stovetop. So what we do is we add these images to the transcription interface, which helps Turkers disambiguate what the audio they're hearing. So we have an image around the narration timestamp, as well as images a quarter second before and a quarter second after, just to add some temporal information. And so for additional context, we also have 10 of these in a row taken consecutively from the original video. So if they maybe can't hear a word very well in one audio narration, they can better get it from another one just after. And to ensure quality, we have 3 people transcribing each audio narration. So how do we get quality from 3 people transcribing these narrations? So first we have we measure the cosine similarity of the word to Vec embeddings. So this will easily identify anyone that's trying to fool the system by typing in something that sounds reasonable, like make the food, but we can tell is completely irrelevant to the audio from the other transcriptions. So we can eliminate these and get a new transcription which is much more similar. So then we want to be able to get the consensus from these 3 transcriptions.
Need go.
So in some cases it's fairly obvious what it is and the workers can identify it, and if there's 2 that match, we can easily say that that's the correct one. And then for common spelling mistakes like need do in the middle, we can just add this to a list that will automatically correct it later on, so we can get better consensus. So in other cases, it's a little trickier.
Grab, walk.
But if one of the workers manages to get it right, we can just manually check this one, and this is much easier than having to type it out. Other cases are even trickier.
Pour thyme spice from lid to Tupperware.
So certain words are hard to tell, and maybe the spelling of other words is tricky. So we can just, from this, be able to type out the correct one. This happens in very few cases. The other thing we want to do is this translation from the other original languages we have in EPIC. So we have 4 other languages. We have Italian.
Posa cannuccia.
Spanish.
Tirar cáscaras.
Mandarin.
关闭电磁炉.
And Greek.
Βάζω νερό στην κατσαρόλα.
Now we found that people could quite easily transcribe these in the languages with high consistency. It was actually more consistent than the English transcriptions, but there'd be some ambiguity in the translations because translations can quite often depend on context. So what we did was we first transcribed these into the native language in a separate process. And then we found all the unique transcriptions we had, because we might have multiple of the same one, and then hired a translator to translate these all into English. And this can improve the consistency. So this kombucha will always be a straw, and we know that that's going to be the same.
Okay, so I'll now talk a bit about the parsing and clustering that we did for the EPIC-KITCHENS-100 dataset. So from the transcribed narrations, we now have a 90,000 open vocabulary narrations. And of these 20,000 unique instances, we had quite a few multiple cases of each one. And we want to move from these narrations to action classes. So for example, we might have debone chicken thighs on the left, and we want to move to separate chicken on the right, being the verb and the noun class. And for this, we use a similar process to EPIC-KITCHENS-55. So first we parse the narrations using Spacy, which is a Python library. We then fix the minority of narrations with missing verbs or nouns. And then finally, we clustered these verbs or nouns into the classes. So to begin with, many of our narrations aren't full sentences, and therefore many parsers can struggle in order to parse these correctly. So we had pick up Tupperware here, and because it's not a full sentence, it can struggle to find the correct verbs and nouns. And one trick that we used from EPIC-KITCHENS-55 is actually to prepend the pronoun I into all of our sentences, and that makes them much more sentence-like for the parsers. However, you can still see here that Tupperware was being parsed as an adverb when it should have been a noun. And we had multiple cases of this throughout the dataset, which we had to fix manually. And another way we used to fix this was to use the multiple parsers from Spacy. It includes 3 models of small, medium, and large. And we use these in a cascade fashion in order to kind of get better accuracy on the parsing, and also so it wouldn't take too long to parse the entire dataset. Another big aspect that we focused on for the parsing was to find compound nouns within the dataset. So with EPIC-KITCHENS-100, for whatever reason, we found that people seem to use compound nouns at a much higher rate than they had previously. So this is kind of something like frying pan contents being a compound noun made up of 3 words. And so this is quite difficult to find. Whereas in this phrase here, I stir frying pan contents, Spacy was able to find the verbs and nouns. It wasn't able to correctly link between frying and contents because it gave this d-obj relationship, which is essentially, it's when a verb is being applied to a noun. And in this case, frying isn't being applied to pan contents, it's just part of the compound noun. So in this case, we actually found the dependency trees from Spacy to be quite unreliable. And in order to do this, we actually had to introduce a load of heuristics in order to find all these compound nouns. And we did this for both new compound nouns from EPIC-KITCHENS-100, as well as the previous ones from EPIC-KITCHENS-55. So they should be a lot more consistent and a lot more accurate in total. So after this parsing, we had 1,020 unique verbs, as well as almost 2,800 different nouns. Now, this is a huge number of classes to predict for, and there's many different overlaps. So we want to, for action recognition or for classification tasks, we want to go down to a single verb and a single noun, which is with as minimal overlap as possible. So again, we did this in a very similar way to EPIC-KITCHENS-55. If we had a narration with multiple nouns, then we actually chose the first one. So for example, if we had the narration cut tomato with a knife, then cut and tomato are the key points of that action, and then the knife is just extra information. For the verb clustering, this was done fully manually. We tried using word2vec or WordNet, the verb hierarchy within WordNet, but we found that the lack of context just wasn't able to give us the correct clusterings we needed. And this was even after using a corpora made up of different recipe books. So for the verbs, let's say we have these 6 verbs here: wash, clean, rinse, insert, place in, and place. We manually clustered them as follows. So we had wash, clean, and rinse together. These are quite obvious, but we ended up splitting the other 3 verbs into 2 different classes. And this was because when we looked at these videos, as Will mentioned before, we found that they appeared in 2 different contexts and therefore would constitute in 2 different classes, because remember, we want these to be as minimally overlapping as possible. For the nouns, we had a semi-automatic approach. So we began with the either the noun itself, or if we had a compound noun, then we used the final noun. So example, for tray, we matched with baking tray and pizza tray, as all types of trays. and then similarly for tin. However, when we looked through these, we found that we might have an example such as baking tin, which does not belong with the other tins. So after our manual kind of reclustering, we ended up with these two classes of kind of moving tin across. So during this step, this was a chance to look at old clusters and update them. And we removed a lot of small classes from EPIC-Kitchens 55. So there'll be cases where we might have only had like less than 5 instances. And one of these was tarragon, which we now assign to leaf. So that's where we have quite a large drop in classes, even though we have a lot more annotations. We also combined others, again, after looking at the context for these videos. So flush was one example where we had in EPIC-Kitchens 55, and this was probably a mistranslation, as we initially believed this was cleaning, but after looking through the video, it was a mistranslation of someone turning off a tap. So we combined this with turn off, and there's a few other examples in the dataset. And then finally, of course, with collecting new data, we had new classes, and lentils was one case which didn't appear in EPIC-Kitchens 55, so there's a new class for that. So as a recap for this step, we first got the part of speech for each word in the narration, and then once we had these verbs and nouns, we then got the verb and noun classes. And then essentially what we've done is we've converted the open vocabulary captions into an action tuple, which can be used for classification tasks.
Hi, I'll talk to you about the process of annotating the start and end times of actions in EPIC-Kitchens. It is done in 2 basic steps, where in the first step we collect multiple annotations for each action, and in the second step we combine those annotations to get the final start and end times. The basic procedure of obtaining multiple annotations for each action can be described by this loop, where videos to be annotated are submitted to Amazon Mechanical Turk, and inaccurate annotations are rejected and resubmitted. And this process continues until all annotations are accepted. The inputs to the temporal annotator are the video, a single timestamp from the narrations, and the action for the given timestamp. And the outputs are the start and the end times of the action. This video shows how the Amazon Mechanical Turk interface works. Initially, we showed to workers video examples with the start and the ends of actions. After that, we saw the video clip with the 10 actions to be annotated, where we highlight in red each action using the narration timestamps, such as the workers know approximately where the action will happen. Then the annotation process begins, where the annotator will press the start button to annotate the start of the action and the end button to annotate the end of the action. There are also the options of going forward and backward with different speeds for finer granularity. To assess the quality of the provided annotations, first we compute the temporal overlapping between all pairs of annotations. Remember that we have 5 annotations for each action. Then we find the most overlapping pair, and we keep these 2 annotations as reliable annotations to compare with the rest. If any of the rest has an IOU smaller than 10% with either of the 2 best annotators, then we add their annotations in the list of inaccurate annotations. So in this particular example, the first and the last annotations are added to the list of inaccurate annotations, while the blue annotation is considered as accurate. If the quality assessment detects a worker with more than 20% of inaccurate annotations, then we randomly sample several annotations from the worker, and we watch the resulting action clips. We reject the worker if the sample annotations are either not relevant to the action or contain multiple actions. After obtaining multiple annotations for each action, we want to combine those annotations to get the final start and end times. To do that, again, first we compute the temporal overlapping between all pairs of annotations. Then we find the annotator with maximum agreement with all the others. And we also find the second best annotator as the annotator with maximum agreement with the first best annotator. Then we drop all the rest, and the final decision will be made based on the 2 best annotators. If their IOU is bigger than 50%, then we take the union of their annotations as the final annotation, and we call this option IOU plus. In a different scenario, where the IOU between the two best annotators is smaller than 50%, then we simply keep the first best annotation as the final annotation, and we call this option IOU. These two videos show the difference of IOU and IOU plus for the action pick up washing detergent bottle. As it is evident, IOU plus alleviates the problem of very dense annotations where the action is not yet completed. Finally, I want to highlight that in EPIC Kitchens, the resulting annotations are very dense and in many cases overlapping. We observe that there are overlapping annotations when different actions are applied on the same object. For example, spooning the coffee into something starts before the action of opening the coffee finishes. And this can be attributed to the ambiguity of the definitions of the start and the end of an action. There are also naturally co-occurring actions. For example, stirring the yogurt takes place while spooning the yogurt into something. Thank you very much.
Hi, I'm really pleased to introduce automatic annotations. We have published two kinds of annotations. One is from mask ASEAN, and another one was extracted by hands object detections, which is a new method proposed in CVPR 2020. We believe such captured objects may help video analysis. Here, we can see comparison of EPIC-Kitchens 55 and EPIC-KITCHENS-100. We can conclude that the annotations of EPIC-KITCHENS-100 are much denser. Specifically, unlike previous dataset, which was annotated manually, annotations of EPIC-KITCHENS-100 were extracted automatically in each frame by both these two methods. I will introduce them in detail. Objects with any sizes, no matter they are big or small, can be successfully detected by mask ASEAN. For example, here, the dining table and the watch. Here we can find some mispredicted objects because of cocoa pre-trained weights. For example, it should be a mug rather than a bowl. However, category of objects which can be found in cocoa can be recognized precisely, such as persons, cups, twisters, and so on. Based on that, we provide around 50 million, 9 million, and 8 million detections for train, validation, and test respectively. The most exciting thing I want to share is hands and object detections. This method was accepted in CVPR 2020. Basically, it is based on faster ASEAN to detect hands and objects. In more details, please read that paper. Here, we extracted the bounding boxes of hands and interacting objects, unlike mask ASEAN, which detects all the objects as possible as it can. This hand object detection algorithm not only detects constituent objects and agent performing action, but also it can recognize the size of the hands. Meanwhile, the video shows that there is a blue or red line between hands and objects. It means the directions and distance from the center of the hands to the center of detected objects. We extracted this information by setting the confidence 0.1 and 0.01 for hands and interacting objects, respectively. So users can play around this data as they need. So this is the part of automatic annotations.
Hi, everyone. We'll try and get through as many questions as you can here. So the first question was from Sanyam, and it says, how do you think the variations due to lighting and different heights and different setups of kitchens might be beneficial? And for that one, we'll go over to Johnny.
Hi. So the different lighting conditions and the variation in the head height should allow some generalization capability. So we have 37 participants with all different heights and everything. So this should allow some generalization to people with different heights. It can't guarantee it's going to be invariance, but it will increase the generalizability to new participants in that way.
Okay, thanks, Johnny. The next question we're going to go through is by Semi Yakioluglu. Sorry if I pronounced your name wrong. Are the splits separated by kitchen person, or is there any overlap between splits in terms of train validation? They're asking in the context of generalization. And for that one, we're going to go over to Mike.
Yeah, so thank you for the question. So the splits were done in a way so that we wanted kind of, so for most of the participants in the data set, they will appear in the train, the val, and the test. Like we mentioned previously, we do have some unseen participants which are only visible in the test just to do the generalization.
Okay, thanks. And we're going to go back again to you, Mike, for the question from Oswald Lance, which is, can you tell if there are zero shot actions in the test set?
So yeah, again, great question. There are a lot of zero shot actions in the test set, and it's mostly like you said, where there's kind of verb noun pairs specifically, not in the training set. We try to keep the number of zero shot verbs and nouns themselves as few as possible, but yeah, there's lots of combinations which are unique to the test set.
Okay, thanks. The next question is from an anonymous attendee, which we're going to go over to Will for, and that says, do the released videos include audio annotations, or do we only hear the environmental sound?
So currently we're just releasing the videos with their associated sounds recorded on the camera. I don't think we have any plans to release the audio narrations, and this is due to privacy concerns. So unfortunately, no.
Okay, thanks. Next question is from Meng Meng Zhu, and that's interesting to see the narration in different languages. Are you going to publish the narration audios? And that was to Mike, but I suppose that's just been answered.
I can expand a bit in that we maybe in the future we will release the actual narrations themselves. The transcribed narrations. So you might have the narrations in the different languages, but we can't release the audio again because of privacy reasons.
Okay. Thanks. And we're going to go back to Mike again for the next question, which is from Edom Desolani, I think. We saw action recognition results over the new EPIC-KITCHENS dataset. Did there happen to be object recognition results over the previous current dataset? In fact, Hazel will probably be better for that one.
So we have some automatic annotations for the objects, but we didn't do any manual annotations this time, so we can't measure it.
Okay, thanks. Next question is from Semi Yakikuglu, actually, which says, in the previous dataset, there are several repetitions, such as washing plates and still washing plates. Does the new annotation procedure address this? So I thought this would probably be Vangelis or Davide to answer this one.
Sorry, could you repeat the question?
So in the previous data set, there were several repetitions, such as washing plates, and then someone after that would say still washing plates. Does the new annotation procedure solve this?
I think we still have this thing of repeated annotations in the new procedure. Maybe
I think if I can comment, it's very difficult for us to know whether it is a continuation of an action. If someone says cut cucumber and then they cut cucumber, we don't know whether it's a new one, right? So we do annotate a start and end time for every narration.
Thanks.
Due to the new, can I just add on? Yeah, sorry. Due to the new narration interface, we found that it was less likely that people would say continue doing this. They would, stop, pause the video, narrate it, and then wait until the action finished. So while there still might be, still washing plates or still cutting cucumber, this is, much reduced compared to previously.
Okay, thanks, everyone. The next question is from Yuta Shirakawa, and they say, does it include instruction on parallel behaviors? So for instance, somebody might be frying whilst washing at the same time. Could Will answer that, please?
Sure, yeah. So we find that there's actually a lot of overlap in actions. So we didn't explicitly ask for this. This just naturally arises from people's behavior in kitchens. So they might be, I don't know, stirring whilst chopping something. And what we found is because of the new annotation interface, people were less rushed. So the density of overlapping actions is much higher in the extended videos that we've recorded now than those in 2018. But they're present in both 2018 and 2020 videos.
Okay, thanks. So an anonymous attendee has asked, is there a specific metric for zero-shot action accuracy on the test set? Will, do you know about that?
So we just evaluate top 1 and 5 accuracy on the test set, and we evaluate on subsets of the test set. Specifically, we have these unseen participants, so we evaluate performance on those, and also on tail classes. So these are where we've got fewer instances, and that will actually include these zero-shot cases, but we don't have a metric specifically for zero-shot.
If there is an interest in the community, this is something we can consider adding. So drop us an email and we can add that metric if that's of interest.
Got another question now by Victor, and that's saying, do you plan to release all the temporal annotations? So Mike, maybe you could have a quick word about what's actually in the pickle files that we're going to be releasing.
Yes, there's a little bit of a talk that I'm giving later about the repos, but in generally we're releasing everything that makes sense to release. So I think there's only a few actions which don't correlate to anything. They must have just been misclicks. Essentially, we're also releasing everything apart from the test set narration, so specifically the verb and noun classes for the test set for the challenges. But otherwise, yeah, we're trying to release kind of almost everything that we can.
Thanks. We've got another one. Somebody, Student has responded. So will that keep the models from generalizing well on the real world tasks? I think that's talking about the GoPro settings. So Johnny, could you answer that one?
Yeah, sorry, my connection went a bit. Can you repeat the question?
Yeah, so Student last time wanted to know about the effect of motion stabilization on the GoPro. And we've said that some participants are carrying out stationary actions. And they've responded with, will that keep the models from generalizing well on the real world tasks?
So this is only the collection of data for the extension. So there is still, there's no stabilization for half the data set that was collected 2 years prior. So we do have the combined data from the extension and this one. And it shouldn't decrease the generalizing capability as well, as long as the camera stabilization was still on. But as we've got the additional data without camera stabilization, I don't see this reducing the ability for the model to generalize.
Okay, thanks. We got one which this will be for Dima actually, which is how do you motivate people to participate in the project and record their cooking videos, and are they mostly students?
They're students and our friends. I think we did bully a number of friends to kind of participate with us. So they're not all students. We have not reimbursed any of the participants. So this was a voluntary task. Remember that the whole project was not really externally funded. So we were running on a small budget. So they were volunteers and we very much appreciate their effort.
Good answer. Right. Somebody else, an anonymous attendee, has asked whether the audio files are mono or stereo. Maybe Will or Vangelis would know about this.
Yeah, I can answer this. They are stereo channels.
Good.
Just to clarify, I'm not sure if they were referring to the narration recordings or the video recording. The narration
the video recordings.
Okay. Okay, great.
Okay, that's all the questions now. We've done 28.
Toby,
yeah.
There are a couple of questions of Xavier Giraud in the chat because it didn't work for question answering. Is it the last question? You can.
Oh, okay, right in the chat. Sorry, I didn't see that.
Maybe we can take them at the end of the Q&A. We're a bit more than the 10 minutes we've allocated, and we have a second Q&A session at the end. So keep typing your questions.
Yeah, please put them in the Q&A rather than in the chat, please.
Yeah, this is the ones we will be choosing. And let me start by the second session. I need to remove this from my face so I can actually see my slides. Oh, interesting. How do I do that? Nope, that doesn't work. 1 second, bear with me. Okay, right. Right, so in the second session, we will be presenting the challenges and the benchmarks up. So as you can see, again, they're short bites and leaving time for you to ask questions. We very much appreciate your questions and comments. This is very encouraging for us. I'll start by talking about the challenges we ran in the last 2 years, and then we will have the 6 challenges ending with what's on the annotation repository and few ideas about the rules of the 2021 challenges, which we will open. And then we'll have time for the Q&A. In CVPR 2019, we had the first round of challenges for 2 challenges, action recognition and action anticipation. This year, basically 2 weeks ago, we had the second round of challenges, including the object detection in video challenge, which I'll tell you a little bit about. It's not one we had exactly continued that is, and we are considering how to continue it in 2021. The action recognition challenge had an increase in the number of teams participating and the number of submissions. And we could see towards the end of the deadline, when we closed the leaderboards, a really very fierce competition to improve on the accuracy performance. We had this S1 and S2 seen and unseen kitchens, and thus we awarded the top 10, the top 3 performances in any of the leaderboards in S1 and S2. And it's really interesting that most of these came from university labs. So even though the data set is huge, it's really great that people are not only proposing solutions through ensembles, but also proposing novel solutions that are pushing the research. In the anticipation challenge, again, we saw an increase in the number of teams participating. We are very glad that probably EPIC-Kitchen is now forming like the main baseline for action anticipation as a principal data set. And we had the top 3 winners from combination of the University of Bonn, National University of Singapore, Maryland, and A-Star Singapore. It's also great that the first team in anticipation was also a top 3 winner in recognition. Very interesting approach if you would like to look at it. In the object detection in video challenge, in this case, we were actually doing manual object annotations, as Jin noted on part of the data set. Interestingly, we didn't find any competing teams in the first year. This increased in the second year. But due to the concept that this is different than standard object detection, due to the size of the data set, these mostly were company teams competing. But again, most of these are producing novel approaches that are based on trying to detect an object when it's occluded or when it is blurred via looking at the context. Interesting and novel approaches for you to look at. We managed to meet in person last year in CVPR in Long Beach and to give the awards in person. The technical report is online. This year, we didn't manage to meet in person, but we ran a virtual session. And again, the technical report was released last week for you to look at all the competing approaches and the teams and their novel approaches. For 2021, and alongside EPIC-KITCHENS-100, we have 6 challenges, 2 of which you've seen, 4 are completely new. And now we're going to go into slide details, if they are different from the previous one, what have we changed, as well as the last 2, which we think are very, very novel, the unsupervised domain adaptation and action retrieval. And we'll start with Will to tell us about action recognition.
Hello. So the Action Recognition Challenge was run in 2018 as released as part of the ECCV workshop. So we'll have a look at first what is action recognition, and then we'll have a look at some of the changes we've made since the previous incarnation of the challenge. So first up, a quick recap. We have a trimmed video that's denoted by a start and a stop time. And the goal is to build a model that can observe this video and then classify the action within. So where we deviate slightly from other action recognition tasks is that rather than asking you to predict 1 label for a video, we ask you to predict 2. So we're asking you to classify the verb and the noun separately. So practically, this typically involves having 2 classification heads on your model. And then the test sets we had in EPIC-Kitchens 55 were these. So we had our training set composed of 28,000 action segments, and then we had these 2 test sets. The first of which included kitchens that had been seen during training. So this was an easier evaluation for models. And then we had the unseen kitchens test set. And this was a harder test of models' ability to generalize to new environments. So now in EPIC-KITCHENS-100, we have a more typical train, val, test split. So where are all these videos now? Well, the training videos from EPIC-KITCHENS-55 are still in training, along with another 37,500 action segments, which are entirely new. In our validation set, we have the entirety of the Seen Kitchens test set from EPIC-KITCHENS-55, but the unseen kitchens test set had to be split, so half of it goes into validation and the other half goes into training. And then finally, our test set is composed purely of new videos. So we have a few subsets of interest in the test set, the first of which are unseen participants, because we have people who are returning, they might be in new kitchens. This is why we've changed the terminology slightly. So unseen kitchens are now unseen participants because you've never seen the participant before and you've never seen the kitchen. So like this is really difficult. And then we also have tail classes, which are a new concept that we haven't introduced before. So let's delve into that in a bit more detail. So to understand these tail classes, we have to look at the distribution of classes in the data set. So here we can see the number of instances for each verb class in the training set. And what you find is that the largest 11 classes account for 80% of the training data. So it's pretty easy for your models to do well on these classes, but the remaining 86 classes only account for 20% of the data. But you know, our model should still work on this, on these 86 classes. So that's what the tail classes are. They are the smallest classes that account for 20% of the instances in training. Now, we also have some changes in metrics. In EPIC-KITCHENS-55, we had quite a few metrics. We had top 1 and 5 accuracy and macro average precision and recall. The latter being our attempt at encouraging people to treat each class as equally important. But it seems that these were largely ignored and people have primarily been comparing models on top 1 and 5 accuracy. So we decided to abandon that, just keep top 1 and 5 accuracy. And in addition to reporting that on the entirety of the data of the test set, we report it both on the subset of instances that come from unseen participants and instances that are labeled with one of these tail classes. So we've got a bunch of baselines for you to compare against. Here are the results of TSN, TRN, TBN, TSM, and slow fast. And this is top 1 action accuracy. So you can see that TSM and slow fast are leading the pack. If we have a look at performance only on instances that come from unseen participants, again, we see that the same trends hold true. But interestingly, when we have a look at performance on the tail classes, the trends are quite different. So TBN jumps from 3rd place to 1st place, and the ordering of slow fast and TSM swaps. So the importance of the tail classes cannot be overemphasized. It's really important that we build models that can work on these classes where we have fewer instances. So we really encourage you to try and boost performance on these. We'll be releasing our leaderboards towards the end of August for you to participate, and we welcome your submissions.
Okay, great. So the aim for this challenge is to supervise an action classifier using only one single timestamp per action, using the same splits that we just saw for the strongly supervised action recognition challenge. So usually, well, we just saw that for the strongly supervised action recognition challenge, we have a start and an end time for each action. For this challenge, we no longer have that. We instead have one single timestamp per action that is roughly located around the action. So we know that the timestamp is somewhere around the action, but there is no guarantee that the timestamp is relevant to the action. For example, in this case, the timestamp for open box is located just after the action takes place. So for this challenge, you will need to train your model on untrained videos where each action is labeled with a single timestamp as well as a verb and a noun label. The verb and noun classes are the same as the other baselines, for the other challenges. So for actions that come from EPIC-Kitchens 55 footage, the timestamps correspond to the narration timestamps that we obtained with the live commentary approach. So we saw earlier that there is quite a large misalignment between narration and actions, and as a result, only 50% of the narration is contained in the corresponding action segments. And the average action to narration distance is about 4 seconds. For actions that we collected for the EPIC-KITCHENS-100 extension instead, the timestamps were obtained by the narrator, and these are much more precise. And in fact, we have about 78% of the narrations being included in the action segment, and the average action to narration distance is under 1 second. Testing is done on trimmed segments, and we follow the same evaluation metrics as the strongly supervised action recognition challenge. And please be fair and do not use the starting times for training at any time. So there are a few difficulties involved in this challenge. First of all, timestamps are roughly aligned. That means that the time for each timestamp can be located over background, or it can even be located over a neighboring irrelevant action. Also, actions naturally overlap and vary in length. Also, we have quite a few different actions in our untrained videos, and the fact that we use weak supervision, but we follow the test protocol as a strongly supervised base, and also adds to the overall difficulty of the challenge. So we provide an initial benchmark for this challenge. We compare 3 baselines, or if you will, 3 kind of supervision, using the same model, which is two-stream TSN in this case. So we are seeing here under strong GT, the model supervised by start and end times. With fixed segment, this is the baseline where we created an action segment of fixed length that was centered on each narration timestamp. And then for the other baseline, we used our previous work published at CVPR last year, where we use sampling distributions that are initialized from the single timestamps and are iteratively updated during training. And these sampling distributions are modeled with a plateau function, and this is why we call this baseline updating plateaus. So from this table, we see that our updating plateaus baseline improves over the fixed segment by 1 to 3% top one accuracy. However, we also see that there is still a large gap between weak and strong supervision. In fact, weak supervision performs around 11% worse than strong supervision. These numbers tell us that, well, they show the challenges, the difficulties that are involved in using single timestamps that are only roughly aligned with the actions in the video. Thank you very much.
Okay. So now I'm going to talk about the detection task. This is a new task that we are proposing with EPIC-KITCHENS-100. And so let's consider an untrained video. This can be a short video or a long one, up to 1 hour or so. The goal is to process this video in order to retrieve the list of all actions that are happening in the video. And each of these actions is a tuple of 4 elements, including starting time, an end time, and a verb and a noun ID. So this is what an action segment may look like in our dataset. And this is what a background segment may look like. So no specific action going on in that case. This new task is made possible by the denser annotations that we have in EPIC-KITCHENS-100. In fact, as compared to EPIC-KITCHENS-55, now we have more actions per video, more actions per minute, and more labeled frames, and a smaller average distance between actions. Also, the action length is smaller in average, and there are more overlapping actions. And so these allow us to be confident that just a few number of actions are in the background, so of missed action are in the background, as compared to EPIC-KITCHENS-55. We consider a detection task rather than a segmentation one because we have many overlapping actions. So considering a segmentation task would have been a natural choice. To evaluate the methods, we considered mean average precision, which is a standard measure for action detection. And we compute the mean average precision at different IOU overlap thresholds ranging from 0.1 to 0.5. And the methods are ranked by the average MAP across the considered thresholds. As a baseline, we consider a standard 2 stages approach. So first, we train a TSN on EPIC-KITCHENS-100, and we use it to obtain per frame features. Then we train a temporal a boundary matching network on these per frame features to obtain action proposals. Each proposal is then turned into detection by classifying it using slow-fast, which was one of the best action recognition methods in our benchmark. In this slide, we show some results of this baseline for different overlap thresholds. And as we can see, even looking at the very small threshold of 0.1, we have very low numbers here. So we have an action MAP of about 6% and verb and noun MAP below 12%. And if we look at the average MAP, these numbers even get lower. And this suggests that this dataset is very challenging for this task, probably because the videos vary in length, and they can be very long, and actions can be very short. So we think this is an exciting benchmark for this kind of task. We also renew our action anticipation challenge, and we change a few things from our previous definition in EPIC-KITCHENS-55. So the task is as follows. So let's consider an untrained video. We wish to predict the occurrence of an action by observing a video segment preceding these actions. So let's consider a trained action. We want to sample a video occurring 1 second before the beginning of the action. And of course, we set the anticipation time to 1 second. So this is fixed as in last edition. But we can change the observation time as we wish, so we can also observe a longer segment. What we cannot do is looking at that gap that you see here. So that segment in between the end of the observation time of the observation video and the beginning of the action. And this is because we want to make sure that we are anticipating what's going to happen in 1 second, and we are not observing the last frame before the beginning of the action, which might be very related to the action itself. Now, by observing this video, we want to train a model which can predict the action that is going to happen in 1 second. So this is the unobserved action that is happening at TS. As with the previous challenges, these verb and nouns have a structured format, so we have to predict IDs. Now, the main difference between action anticipation and action recognition is that in the case of action anticipation can have different correct answers, while instead in the case of recognition, we usually have only one possible correct answer. And let's see how this affects our evaluations and why we change the evaluation. So if we consider an observed segment and we ask ourselves what's going to happen in 1 second, then maybe a few actions may naturally follow this observed segment, while instead other actions are very unlikely. However, when we create our dataset, we are going to sample a pair of observed segments and label from the videos that we have. So we end up with a pair which associates a single label to an observed segment. But yet we want to evaluate this in a realistic way, which means that if this is the correct label, the predicted label, then it's fine. But the model may also predict other actions which are not in our ground truth. So in the previous version of the dataset, we evaluated action anticipation using the same evaluation measures considered for recognition. In particular, these were top 1 and top 5 accuracy and macro averaged precision and recall. Now, these have some shortcomings. In particular, top 1 accuracy assumes that only one possible answer is correct. So in order to obtain a 100% top 1 accuracy, the model should always predict the exact action that is appearing in the dataset. And this can only be done by overfitting to the test set. And of course, this is not a desirable behavior. We can use top 5 accuracy to relax this constraint, but this is still biased because of the long tail distribution. Indeed, we can obtain a high top 5 accuracy by ranking higher only the most frequent classes without even looking at the video. Now, what we propose in EPIC-KITCHENS-100 is to evaluate action anticipation using mean top 5 recall. And this is done by considering an anticipation as correct if the ground truth label is among the top 5 predicted actions. So let's consider this example where our model predicted A, C, D, and F. If the ground truth action is D, since D is in this list, then this prediction will be considered as a correct one. Let's consider another example where the top 5 predictions are B, D, A, and G. If the ground truth prediction is E, then in this case, this is a mistake. Now, we compute results per class, as usually done with precision and recall, and then we average to obtain a single measure. And this allows us to balance for the long tail distribution. And similar to action recognition, we evaluate on all instances, unseen participants, and tail classes. As a baseline, we consider our previous approach, which is rolling and rolling LSTM. These obtained top results in the last edition, in the 2019 edition of the challenge. So we chose this as baseline. And we compare this with a simple chance baseline, which predicts actions following the frequencies observed in the training set. As we can see, the task is very challenging with this dataset and with this evaluation measure. Indeed, in overall, we have an action mean top 5 recall of slightly above 10%. And also verb and noun, they are about around 25%. If we look at unseen participants and tail classes, the results get even worse. So we think there is a lot of room for improvement on this dataset with this new measure and this challenging task. And thank you.
Hi, I'm going to be talking about the unsupervised domain adaptation challenge for the for EPIC-KITCHENS. So there's this domain shift that occurs with the data collected in 2018 of EPIC-KITCHENS-55, and then the data collected for the extension 2 years later. So this domain shift occurs even for the same participants who recorded 2 years before and also the 2 years after. So we call the data collected in 2018 as the source domain, and the data collected by the same participants 2 years later as the target domain. So to show you that there is this domain shift, we have trained a TBN model on the source domain and extracted features on both on different videos from the source and the target domains. So we can see from the UMAP visualization of these extracted features that there is this domain shift. The distributions of all examples do not overlap. One reason for this domain shift is that some of the participants have moved homes and therefore are filming in a new environment not seen in the source domain. So we can see that, participants who have changed home, there is this clear domain gap with features features well separated in feature space between the domains. However, for participants who have stayed in their same home between the source and the target, the features still do not overlap. This can be due to the different cameras that were used, as well as the different objects being interacted with and the activities in the change in activities between the source and the target domains. So we propose this unsupervised domain adaptation challenge. So we use labeled data from our source domain in 2018 and unlabeled data from our target domain, which is collected in 2020. The aim is to maximize action recognition performance in the target domain. The benefit of this challenge is that it doesn't require the expensive annotation process when collecting new data 2 years later. So it avoids the annotation requirement when collecting future data. We define a series of challenge splits. These contain the 16 participants who collected data both in 2018 and in 2020. First, I'll explain the training split, which consists of source data, labeled source data from 2018, as well as unlabeled target data from 2020. So you can train on, so you train with both of these, which we call as source train and target train. These contain the same 12 participants. So in total, we have 12 participants, of which there's footage in the source and the target. You will then evaluate your model on different videos from the target domain from the same 12 participants. So in total, we have 16 participants, and we've left 4 participants out for hyperparameter tuning. The reason behind this is that the target training set is unlabeled. Therefore, people can't evaluate the models to select hyperparameters. So by using having these 4 different participants held out for validation, this allows people to then evaluate their models and then retrain on their training set. So we have here a similar setup for the training splits. We have a source validation and a target validation. So you can train on your labeled source and your unlabeled target. However, in this case, you can now evaluate on your target as if it was labeled to determine your hyperparameters. You then use these hyperparameters to train a completely different model with the data from the training splits. So the final model should be trained only on the training splits, but you can use the hyperparameters found from the validation. For baselines, we have extracted features from the TBN architecture trained on the source domain. We can see the plots of the features to remind you that there is this domain gap. For baselines, we have used the architectures defined in Chen et al.'s paper from ICCV 2019 on temporal attentive alignment. First, we have a model that is trained purely on source data. The second is the unsupervised domain adaptation approach from temporal attentive alignment, which uses unlabeled target data to improve the action recognition performance on the target domain. Lastly is an upper bound, which is if we had labeled target data available, what performance can we achieve? Note this isn't really a baseline, but it's just to tell you how what is a theoretical limit for unsupervised domain adaptation. So we evaluate both on verb, nouns, and the combination as actions. And we can see comparing the bars in blue and the bars in gray, we can see that the gray bars, which is with domain adaptation gives an improvement. So utilizing unlabeled data improves the transferability to the target domain. The orange bar, which represents our model trained on target labeled data, shows the upper bound, and we are far from it, showing that there is a large potential improvement for future research into domain adaptation to improve this benchmark. Thank you very much.
Okay, so I'll just give a few minutes overview for the action retrieval challenge. So this is a new challenge for EPIC-KITCHENS-100, and different from the previous challenges, it's not a classification task. So we're not using we're not trying to predict the verb and noun classes. Instead, we're using the transcribed narration that we collected during the dataset collection. So instead of the separate chicken that we predict for classification, instead what we're looking at is the deboned chicken thighs, which was the original narration. And similar to the video retrieval challenge from other datasets, given a video, we want to find a corresponding caption. So for example, for this video, we might want to find put bread on cooling rack. However, we differ from other video retrieval challenges in that in our data set, we have a lot of captions which could be quite similar and semantically relevant. And we want to find all of these relevant items from the other modality via ranking. So given a single video, we want to find all the captions that are relevant, or given a caption, we want to find all the videos that are relevant. However, that brings up the problem of how do we determine relevancy between two items. And in fact, we do use the verb and noun classes for just for this relevancy. And we use the average intersection over union between the verb and noun classes to find the relevancy score. So for example, we have two captions here. However, the same process can be done between a video as well. And these are cutting a pizza using a slicer and slicing a pizza. So firstly, we look at the verbs and nouns in both captions. And then for the verbs, we can see that they both share the same verb class. So when we put this into the intersection over union formula, we get a score of 1. For the nouns, we have a slightly different story in that one caption says using a cutter. Therefore, we have an extra noun for this caption. And then when we put this into the IOU formula, we only get a score of 0.5. So in total, these we can assign a score of 0.75 between these two captions for their semantic relevancy score. So now that we have the score, we can also evaluate, and this is done using the normalized discounted cumulative gain metric. And this is important because we have differing levels of semantic relevance between items, and we wanted to make sure that we look at the full ranking in order to evaluate this challenge. So for the video on the left, we might have n captions on the right, and ideally we'd have this top case where we go from highly semantic relevant captions retrieved first, and then semantically irrelevant captions retrieved last. However, during training and kind of testing, we might have this bottom case where we have a highly irrelevant caption in the top 3, or we have a most semantically relevant caption at the end, and therefore we'd get a lower score of 0.6. And then for the benchmarks for this challenge, we include the chance benchmark in orange, and then included the kind of multi-layer perception, which is a standard task for action retrieval. And then also our previous work in ICCV last year, which is the joint part-of-speech embeddings in gray. And you can see that for this new data set and for the new challenge, still splitting the verbs and nouns into their separate embedding spaces is important, giving you a large boost in accuracy. So kind of as a recap, we're doing both video to text retrieval and text to video retrieval as part of the challenge. As access to the narrations are required for the challenge, we're actually using the validation set as this test set. So this means that when doing this challenge, you will have information on the relevancy between videos and text, but these should not be used for the challenge. And we do reserve the right to check everyone is not doing this during the challenge. More information can be found in the paper and supplementary material, but I am happy to answer any questions about this challenge later on in the Q&A. So now that we've heard about all the challenges, I'll just go through the annotations repo. This is very similar to the last repo we had, but there's a few new additions and changes. So the new repo can be found at the following link. Note the EPIC-KITCHENS-100 annotations. And again, we are releasing the files in both CSV and Pickle formats for ease of use. And for the 3 main splits, so these are used for the action recognition challenges and those based off of those, the trained validation and test files can be found under the important files, as well as the noun classes and the verb classes. For all the test files, you will note that they've been labeled as test timestamps. So we're not actually releasing the verb and noun classes for the challenges themselves, so that you have to submit on the leaderboard in order to evaluate on the test sets. I will also highlight that although not new for this year, we do have, for all of our pickles, we now have kind of metadata for them so that you can check which version they come from and even check down to the commit so you can make sure that you're using the correct set of annotation files. So what do one of these files look like? Here we have the EPIC-100 training set, and we have 15 different columns. Most of these will be familiar from those who've used the previous data set. However, we've got two new columns. Firstly, the narration ID. And instead of using the unique integer ID that we had before, we're now having a unique ID that is based on the participant ID, then video ID, and the narration ID itself. So you can see here, this ID is for the 0th annotation, sorry, the 0th narration from the first video and the first participant. The other new thing this year we have is the narration timestamp, and this will be used for the Weakly-supervised action recognition challenge. And this was collected, well, for the videos collected from EPIC-KITCHENS-100, this was collected as the time when the person paused the narrator. For EPIC-KITCHENS-55, this was the time when the YouTube captioning software kind of aligned their captions to the video. And I will note that for a few videos or a few narrations, we were unable to match these directly. So this narration timestamp does have a score of none, unfortunately. So for the domain adaptation and the retrieval challenges, as we've just heard about, they will have slightly different splits, and we provide the corresponding splits under the additional files for ease of use, so you don't have to find them yourselves from the narration IDs. And then another new thing this year, for each of the challenges, we've got included a quick start guide. So if you want to get up and running on the unsupervised domain adaptation challenge, then there's a few easy pointers for how to do that. And then for in order to download the videos, we've released a new download script as of this morning. So this will replace the old download scripts that we had previously. And this was written by Davide, and it's done a really good job as it allows you to download both the EPIC-KITCHENS-55 videos or the EPIC-KITCHENS-100 videos, and also allows you to specify exactly what you want to download. So if you've already got the EPIC-KITCHENS-55 videos, then you can specify just the extension. So yeah, these are the two links. Again, you can find them on the EPIC-KITCHENS GitHub, or if you go to our website, they should be easily findable there.
Quick ideas about the 2021 challenges, rules, and dates. So as you've heard, we have 6 planned challenges now for 2021. The baselines we already have and the evaluation metrics are in the archive paper. We can revisit them. We talked about some zero shot, but basically this is what we're planning to use. You can also note that we have, you can already run your methods on the validation set. Because we provided the result on the validation set, you can already experiment how well does your method do compared to the baseline. The test set will remain closed, and you'll be able to do that after the leaderboards are open. We believe we'll use not exactly, but very similar ideas to the 2020 challenges. So there'll be a particular format for you to upload your results. Registration will be based on institution, 1 per team. There will be an overall maximum and a daily limit. The idea is that you should not try to overfit to the test set. That's why the validation set is there for you to try different approaches. The challenge date will close similarly towards the end of May 2021, and we hope to have the first set of winners for EPIC-KITCHENS-100 alongside CVPR 2021, of course, subject to the workshop being accepted. But we do genuinely hope that this time we will be meeting in person to tell you about the winners and the methods that have been used. Any inquiries you have, we have like a general email that kind of helps, not directing it to a particular researcher. Kindly note that all the effort we're doing is voluntary, and most of the people are doing this alongside their PhD and their research work. So while we are very much there to help you, please try to avoid attempting to cheat the rules or break them, because it just means more time for us, and we will ban indefinitely any attempts to do that. We don't compete in these challenges, so this is very much a voluntary service. We are interested in new challenge ideas, whether for next year or for later. You can run your own challenge alongside EPIC-KITCHENS-100. And as you've seen from our initial motivation, the idea is 1 set of data, lots of potential tasks. So do get in touch if you have any ideas on that.
And yes, it's time to questions. So thank you, all the speakers, And the first question is for Dima, I guess. I don't know why. Okay, the first question is for Dima. Is there one-to-one correspondence between participant and kitchen? Is from Xavier.
So the participant ID is a participant ID. Whether they've changed kitchen or not, they maintain the same participant. So that allows you to track the same participant, whether it's in the same kitchen or not. So yes, what we have is a participant number, not a kitchen number.
Okay, the second question is from Ragaba, and it's for Davide. If the object of interest goes out of the camera field of view completely during an action, how are the annotation provided? Will it consider multiple actions or just one action?
So first of all, there is always one-to-one correspondence between timestamp and action. So we always have single actions. So there is no concept of multiple actions. And if the action is not visible or the object is not visible, well, that's part of the challenge, right? So we just use as supervision what the narration timestamp gives us. So we consider everything. We don't manually filter any timestamp based on what's the content of the corresponding frame.
Great, thank you, Davide. The next question is from Victor, and Antonino will repeat it. Why did you pick IOU threshold between 0.1 and 0.5? Is because actions are short or due to the poor performance of 0.5 or 0.5?
So I would say it's a mix of these two motivations, plus we found that agreement, as we mentioned earlier in this webinar, agreement between different annotators is not always very large. So actually what we found out is that usually this agreement drops down to about 0.5 in many cases. So this was one of the motivations. Then, of course, short actions are to obtain a very large IOU, and of course the baseline, I mean, is scoring very poor already on 0.5, so there was no motivation to investigate going beyond that. Of course, if methods prove to be accurate enough, we can change these in the future, and we can have the standard, which I know is from 0.1 to 0.9, that still can be done.
Okay, thank you, Antonino. Another question for Antonino from Siddhant. Can we consider the MAP score for the task of action anticipation? Antonino?
Okay. So I think there are, yeah, can you hear me?
Yeah.
Yeah. Yes. I think there are two scores that are usually referred to as MAP. And so if we consider the same score we used for detection, so the MAP in the sense of detection, of temporal detection, then what we considered in this case was not a temporal detection of the future action, but it was more like a classification. So we know when the action starts, so we know when to sample our past, and we just want to retrieve the class. So in this case, MAP in the sense of detection, of temporal detection, would not apply. Of course, it would be interesting to generalize this task to something more, I mean, complicated, where you want also to understand and to anticipate where the actions start, but it's not trivial to understand how to process the video from the past. If you refer to MAP as the measure used in retrieval, then, well, the point is that MAP is based on a precision, and in this case, it's not really possible to evaluate a precision, because precision means that you are checking if your predictions are correct. While instead, we don't know if all predictions can be correct. We only can check if the ground truth prediction is among the predicted actions. So that's why we turn to recall rather than a precision. And since mean average precision is based on a precision, that's one of the motivation why we just used mean average precision.
Thank you, Antonino. Question from anonymous attendees. This is a very interesting benchmark. Thank you. Can you also please provide a few insights into what additional challenges does Egocentric brings into unsupervised domain adaptation? And Jonathan is going to reply to this.
Thank you for your question. So the first thing to note that we are using video, which is also has seen increasingly more attention, but still there hasn't been very many large data sets for unsupervised domain adaptation video. To handle video for domain adaptation is still something which is an active area of research. But unique to our problem as well, we've got this domain shift of 2 years on. So this is particularly interesting for Egocentric, where we have someone who has a camera and records, but how does that model change over time? So 2 years later, does it still perform well? We've shown that it doesn't. So there's applications towards this lifelong learning, which I think is extremely interesting, and it's an unexplored domain gap, which is not seen in other areas. Thirdly, most of the domain adaptation data sets for video have been working on coarse-grained actions, while we're working on fine-grained actions. So we have lots of different actions being applied to, so the same action being applied to lots of different objects. And in our target domain, we have now these unseen different objects. So we can explore how the domain bias when you perform the same actions to new and novel objects, which is, I think is also unexplored.
I'll follow that up to say the unsupervised domain adaptation aspect could apply to all the challenges, right? So you can say unsupervised domain adaptation for action detection or for action anticipation. Our initial idea to go for recognition is the presence of the only work that is before on anything to do with unsupervised, and that's from ICCV as well as our work. This CVPR focuses on recognition, so we thought that might attract the biggest audience, but you can see UDA being associated in the future with all the other challenges.
Yes, and also Dima, let me say that you can look at the data sets and you can come out with other new problems. So that's you have the data, you have the labels, so you can build some new problems on top of it. Thank you for the answers and the questions, and we'll go for the questions of Victor's for Mike. Is this video to text was about the retrieval task or moment retrieval? And in Victor is pointing out about the video to text MSR VTT alike or moment retrieval Hendrix ICCV 2017.
Okay, good questions. So in this setup, it's more akin to the MSR VTT case. However, in MSR VTT, generally you're trying to find one caption out of the 20 that were assigned to that video. In this case, we have multiple caption. Well, we have one caption per video, but we're also allowing captions for other videos to be seen as relevant according to the semantic relevancy score that I explained earlier. So it's much more like MSR VTT, but we now have more captions per video.
Thank you. Another question from Victor for you. Did you collect multiple captions, or are those coming from the narration? The narration might be very similar. Does the video text embedding or model might lack of diversity? No?
So again, good question. Like I just said, we do have captions from different videos, so the narrations that we're looking for could come from different videos. In terms of variability, I don't think this will be the case. We still have quite a large number of unique captions that are still important. And when we look at the kind of long tail classes, we find that there's still a lot to kind of go for there. So there's a lot of kind of missteps being made by models.
So to follow up on that, I think it's like we use a trick. Instead of collecting multiple captions, what we used is we use our classes to link captions that had been labeled by other people. So that means if someone is saying put down plate and someone is saying place plate, they are different captions by different individuals, but we are linking them as potential retrievals through the classes. So instead of going and collecting additional captions, we're utilizing the captions we have to produce these multiple captions.
Yeah, exactly.
Okay, there is the last question was on the chat. Probably Will can help. Is multimodality a key for dealing with the tail, or do you think more tweaking was missing on TSM and slow fast?
I think the multimodality aspect probably helps for sure, because there are some very discriminative audio cues that TSM and the ordinary slow fast aren't going to pick up on, but TBN is. But the models could probably benefit from hyperparameter tuning as well. I mean, we were primarily looking at the top one action accuracy on the test set rather than, or on the validation set, rather than looking at performance on these tail classes when optimizing them. So that's unexplored. I don't know if Vangelis has any other follow-up comments on that.
We also observed that averaging different segments, different snippets from the video also helps for the tail classes, because one thing that we tried is to use just a single segment, and then the performance on the tail classes drops. So it is two things. It is the multimodality and also averaging predictions of multiple snippets.
Okay, thank you guys. There is the last question. If I think Dima can reply this for all of us, considering the idea of the end-to-end training, basically, are you going to release the per frame feature for detection and retrieval, such that the researcher can play with the model architectures?
I think this is also a question for Antonino, and probably that's something we have not agreed on. I don't believe in these pre-extracted features. I think they really limit the ability of people to explore. The models are still developing at a very, very fast rate, and pre-extracted features of today will prove very quickly not most useful tomorrow. So I am a person who believes in end-to-end learning. I believe Antonino has tried other approaches. I think this is a question still open for discussion. We kind of looked at frame level at some point, even for the 55, and it was like gigabytes of data. I'm not sure how people do that efficiently. If you go to something as small as 512 features, which I think is useless, this is very small. If you really have rich features, multimodal, they're too huge that I don't see the value. I don't think we have an answer for that. If you have a particular proposal that you would like, that's something that would be interesting. Notice that we also have the test set, and we would not want to jeopardize any knowledge about the test set actions as we extract features. So we'll have to be careful in doing that.
Yeah, I would just like to add.
Yeah, exactly. Was asking Antonino to add about.
So I think even if there is not a plan at the moment, at least to release these officially with EPIC Kitchens, of course, probably as it happens in the last edition of the dataset, researcher will share features, and at some point there will be a set of features which might not be the best, but they might be helpful, especially for people who don't have the compute capability of training a model end-to-end. So I still think they can be helpful. Of course, they have limitations, but I'm sure that at some point there will be some features shared.
Yeah, and for sure, probably we can share for anticipation, but let's see, we will discuss internally. Thank you all. I don't see other questions, so probably we can go ahead, and I want to say thank you to all the speakers actually, and also all the attendees to be here with us until late. And going ahead,
I think you just need to click
yeah. I want to announce our workshop, which will be enjoined with the ECCP 2020, the EPIC workshop, and this here will be in August in Glasgow, actually, all we know is that ECCV will be fully virtual, and we are going to have a virtual workshop. So check online to know how to attend the workshop. And regular paper and extended abstract submission is open. You have time until 10 July for the submission for regular papers, and 17 July for extended abstract. And we have a good lineup of speakers with Jitendra Malik, Professor Jitendra Malik, Bernard Kahneman, Federica Bogo, and Richard Newcomb, which will be with us to discuss new things about egocentric vision, and will address news on the people of the field. With this, I want to thank you again, all of you, for attending this workshop. It was a webinar, and all of the speakers, and we hope that EPIC Kitchen 100 will allow you your research to reach new heights. Thank you all.
Thanks, everyone. We will conclude the webinar now. There will be a recording of this available already on YouTube. Please direct us to our questions. If you try to download the dataset, maybe tomorrow there might be a little bit of pressure, let us know, but there are torrents for you to also download. And let us know if you have any questions on the webinar. I can stop my sharing. Okay. Did I stop sharing? No, I think that's us. So on behalf of everyone, we thank you all for staying.
Thank you all.
We appreciate it. Have a good evening.